Salty Math 101. Learn some math with fish for fun.
Hey, okay. Today we will be learning grade 7 lessons. Let's pretend that you finally graduated from 1 plus 1, and now we're gonna move on to binomials. Yes, we are now going to binomials. Super shocking, isn't it? This will be our lesson for today. It's called Square of Binomials. I don't know if that's the name, but it has the word binomials. All right. So so I'm gonna teach you how to solve for the square of binomials. But first of all, what's binomials? Well, this is an example of binomials. X plus a banana to the power of 2. Oh, wow. Oh, you trip. Okay, I'm just kidding. So it's actually this an example. X plus a 2 to the power of 2. So you must be wondering, how do we solve that? Well, what are we even supposed to find? Well, you see, we're just supposed to simplify this, you know? Let me teach you how. This is the answer. X squared plus a 4x plus 4. Yes. So, whoa. Oh, Professor Salty, how did you do that mentally? Well, you see, I'm a genius, so yeah, and you're stupid. I'm just kidding. You're not stupid. Don't worry. So I'll teach you how to get this. But first of all, there are many things we have to learn, like this term called like terms. Yes, you must be wondering, what's like terms? Well, you see, let me give an example. The 3, 5, or 6. What do you call these? Okay, what do you call these numbers? You call them whole numbers. Yes, they are considered whole numbers. Can you add them from each other? Can you add them together? Yes, you can. Can you subtract them together? Yes, you can. Can you multiply and divide them together? Yes, you can. And that's what makes them like terms, because all of them are considered whole numbers. Next, what about this? X or 2x or 5x. What do you call these stuff? Well, you see, in math, guys, we don't just do numbers. We have letters as well for some reason. So x, like x, and x. What do you call them? Well, I actually forgot the term, but I think it's called variables, if I'm correct. Correct me if I'm wrong, because really I'm just doing this based on my memory. I think if it's called variables. If not, then I'm gonna kill myself. So like, same thing. All of these are called variables. Can you add them? Yes, you can. Can you subtract? Yes. Multiply? Yes. Divide? Yes. So they are called like terms because they are, similar from each other. They are alike. So like terms. Why can't they just call it alike terms? But anyways, like terms is shorter, so I think that will work. So I'm gonna give a situation. What if they say 3 plus 2x? Can you solve them? Can you solve them? Well, you see, you can't do anything much because this is already solved. This is already the answer. So you just write down the same thing because there is no like terms. You can't add them together. You can't say 3 plus 2x is equal to 5x because this is a whole number. This is a variable. These guys are different thing. It's like this is a circle and this is a square. Can you add circle and square? No. Well, how's that gonna look like? It's gonna look like this, and that's not the same thing. Anyways, you see my point. Yes, this is like terms. This is like terms. These two are not like terms. So this is already the answer to that. But what if? What if you say 3 plus 2x plus 6 plus x? Okay, you're like, oh, I know the answer, Professor Ray. The answer is still the same. The answer is 3 plus 2x plus 6 plus x. Wrong! It's wrong. Well, this is where we apply finding the like terms. When someone tells you to find the like terms, basically you have to find the stuff here that are similar to each other. For example, 3 and 6. These two are whole numbers, okay? So it's like a step-by-step process. First, you find the like terms. Let's find the whole numbers first. So 3 and 6. So write that down. 3 plus 6. And what about the variables? 2x and x. So you write that down. 2x plus x. There you go. So, can you add these two together? Yes, you can. So you write, what's 3 plus 6? 9. So you write 9. Can you add these two together? 2x plus x. Yes, you can, because they are like terms. So you add, the answer is 3x, and there's your answer. You cannot change that because that is your final answer. That is like terms. Now you know what like terms are. Let's move on to solving square of binomials. And this is the quite complicated part. Oops, wrong. Let's just answer here, shall we? So, we'll use the same example, and we'll see how we got this answer. Okay, so first, let's write down the same thing: x plus 2 to the power of 2, and then you see this thing right here. Okay, think of that as, okay, it's number 2. So basically, you write it 2 times. Yes, you write it 2 times. See, this is what it means. If this is 3, well, that's not a binomial anymore, because from the word bi, aside from being gay or whatever they're called, now in the concept of math, bi means 2. So we won't be using 3, we'll be using 2 only. That means you only have to write it 2 times. Okay, hold up, let me just, there you go. So yeah, how do you solve this? Like, how do you get this answer? Okay, let me teach you. Okay, this involves multiplication, and here's the thing: in multiplication, you can actually multiply variables to whole numbers. You know, I'll just show you an example. Okay, and like terms, it doesn't matter in this square of binomials anymore. Okay, so first, here's how you do it. X times x. Oh yeah, by the way, if you multiply variables, let's say for example x times x, we won't be doing like this anymore because it's gonna look so weird. So x times x, from now on times is circle. X times x is x squared. Okay, confusing, right? It's different from x plus x is 2x, and x plus x as x squared. These guys are not like terms. You can't just say, oh, the answer is 2x squared. No, that's wrong. Basically, the answer to that is still the same because they are not like terms. So that is already the simplest answer. So you must be wondering, how did we get this? Oh, well, okay. I'll give you another example. Let's say x times x times x. How many x are there? 3. So you write that down. 3. Okay, what about this? X plus x plus, x plus x plus x. What do you get? You get 3x because there's 3 of them. You see the difference? If you multiply them, the number goes on top of the x. But if you add them, the number comes before the x. So that's an example. Now let's go back to where we were, shall we? You see this? X times x. Okay, x times x. How many x are there? There's 2. So you write 2 here. Okay, but we don't say it as x2. We say it as x to the power of 2. Next, so we're done with that step. Next is the next step is to multiply x to 2. Okay, so x times 2 is x times 2. Right, 2x. The answer is 2x. There you go. Now we're done with now we're halfway there. All right. The next step is 2 times x. Okay, what do you get 2 times x? What do you get in 2 times x? Well, you get 2x. Again, what about 2 times 2? You get 4. So you see the pattern. In the first part, you just have to multiply this. So see, you multiply them. And the next one, you have to multiply this from there. Then the next one is multiply this. And the next one is multiply this. So you understand now? You understand now how we got this? But Professor Salty, it's not the same as this. Well, this is where we start to apply finding the like terms. Okay? So, is there anything similar to this in this equation? Are there anything? Is there a like term here that is similar to this? No. So just write that down. What about number 4? Do you see any whole numbers here? No, the only whole number here is this one. So you write that down. Then, what about this? Are they similar? Yes. Are they supposed to be added to each other? Yes. So how do you add them? 2 plus 2. Write that down. And then the x, just write it down like that. Okay? So, this is how we got the answer. Oh, very easy. Let's have another example, okay? Yes, that's right. Oh no, this is my brother's drawing. We have to find more spaces. We can make we can make use of this. Okay, let's solve another problem. Let's say x plus 7 squared. Okay, now you know why it's called square of binomials, because you know this is a binomial. Okay, and then this is called squared, or to the power of 2, but I prefer to call it squared because it's easier and it's shorter. So yes, following the step, this is the given. Step 1, you write them both down, right? Step 2, you multiply. So x times x squared. X times 7 is 7x. 7 times x is 7x. 7 times 7 is 49. Next, third step is to find all the like terms. Is there a like term for x squared? Is there any other x squareds here? No, so just write them down. How about 7x? Are there any more x's here? Well, yes, there's another one. See, these two are like terms. So you put them down. So 7 plus 7, 14. There you have 14x. What about 49? Is there any other whole numbers here? None. Only 49. So you write that down. And that is your answer. Congratulations. Yay, you win. Yeah, so before there's one more thing. What if this is the case? Let's say x plus 3 and then x plus 2. Oh my god! It's different. It's a problem now. It's so easy. You know, you can skip step 1 already because you know there's no more this thing. You can skip that step 1 and move on to step 2. So this is step 2. Step 2, x times x squared. X times 2 is 2x. 3 times x is 3x. 3 times 2 is 6. And there. The third step, find all the like terms. So, is there a like term for x squared? No, only this one. So write that down. Is there a like term? What about this? Is there a like term? Well, you see, this is a variable. This is also a variable. Even if they are different numbers, they still have the x and they are considered a variable. Okay? Okay, so you add them. 2 plus 3, 5. 5x. What about this? Is there any other whole numbers? No, there's only 6. So you write that down. And that is your answer. Congratulations, you just learned the square of binomials. Okay, just to clarify. these numbers are whole numbers. These guys, any letters, they are variables. These guys, these are also variables. But it's different from this because it already has a squared thingy. It already has a number on top. Same goes for these guys, which you will learn later because we don't want to learn trinomials yet. We'll only stick with binomials. So let's scratch that out. Yes, so this is only what you should remember in binomials. Whole numbers, variables, and variables that are squared. So yes, that is all you have to learn, and then you're all good to go. So before we end this video, I would like you to answer something which is complicated. So I want you to answer this. See? Wait, oh yeah, by the way, this is not similar to this. If it's x, the only like terms there is x, or 2x, or 3x, or any number. But x is not like terms to y. Okay? If it's y, the only like terms there are 2y, 3y, y. Okay, yes, so that so back to the thing I'm supposed to give you to answer. So let's say y plus x. Whoa, that's a hard thing now. And then to the power of 2. So if you know the answer, you better type it down in the comments. If you get the wrong answer, then you suck. Okay, bye.